My name is Ben Teese. I work for Shine Technologies, and I'm here to give you a little bit of an introduction to AWS Lambda, a recent new offering from Amazon Web Services that I think is pretty exciting. So the agenda for this talk, we're going to start off just by giving a quick overview of what Lambda is. Then I'm going to give some examples of Lambda in action. And finally, we're just going to talk about some of the implications of Lambda, specifically this notion of a serverless future that people are starting to talk about. So I guess the first question is, what is AWS Lambda? I think a good answer is really it is functions in the AWS cloud. And it can be JavaScript functions or Java, actually. Both are supported. In this talk, I'm going to focus on JavaScript. But if JavaScript's not your thing, you can always give Java a go. Now these functions can be triggered by a number of different sources. S3 buckets, things being added and removed, Kinesis streams, simple notification service messages, DynamoDB events, Cognito, which is Amazon's kind of identity related offering. All of these things can trigger Lambda functions if you configure them that way. And finally, you can actually, this isn't strictly speaking an event source, but you can also invoke Lambda functions via Amazon's API gateway, which has some really interesting use cases and implications that I'll get back to later on. An important thing before we take this any further is that this stuff isn't available in the Asia Pacific Sydney region, and furthermore, or Lambdas aren't available in this region, and furthermore, Lambdas in other regions, which you can run from Australia. The catch is they can't access Amazon resources in the Asia Pacific Sydney region. So for example, you had an S3 bucket in the Sydney region and you were trying to write a Lambda function in US West Coast, it's not going to be able to see it. So the basic implication is that really this stuff probably isn't ready for prime time unless you're willing to work in a region outside of Australia. Okay, so the first thing to know about AWS Lambda is that really it's just Amazon Linux under the hood, and Lambda is managing the process of bootstrapping instances of Amazon Linux and running your node program inside of them. So if you were to do this without Lambda in the past, you might have created an EC2 instance from an AMI, it would be running node in it, you deploy your code to that instance and crank up the node server and just have it sitting there waiting for requests. And Lambda just does all of that for you automatically, which is pretty cool. But you can also, because it is an Amazon Linux instance, you get temp space. I think you get 500 megabytes of temp space, and there's various things that are installed in that instance, like Python and Ruby and image libraries, all sorts of bits and pieces. So, and you can fork out other processes from your Lambda function in the instance. So that's pretty cool, and it's worth knowing. There's not a huge amount of magic involved when you think about it. The cool part is that Lambda gives you auto scaling just out of the box. So it will instantiate enough instances to support all of the requests that are coming in. And it will also handle monitoring for you and logging, and you just get all of that out of the box, which is really cool. You don't have to do it yourself. Another difference between AWS Lambda and things like EC2 is that in EC2 you really pay for the amount of time that your instance is up and running, for example. Whereas in Lambda you pay on a per call basis. Each call to your Lambda function, you're charged a small amount, and it is a very small amount. I think it's the first million calls are free, and then each million per month after that is like 20 cents or something like that. You're also charged additionally for the amount of time that each function runs every time, or that the function runs for each time that it's invoked. If it runs for 10 seconds, you'll be charged more than if it ran for 3 seconds, and so on. You can also allocate memory, or vary the amount of memory that is allocated to your Lambda functions. And the maximum amount of memory that you've allocated to it, or that you want the Lambda function to be given, affects how much you're charged, what your time rate, what your rate of charge is for the amount of time that your function runs. Okay, so we'll get into some examples. Shine has worked with Lambda functions in the past, although it's been in kind of an unusual situation. We have a team of DevOps engineers and amongst other things, and one thing that they've been doing recently is using AWS Lambda to coordinate setup and configuration of other Amazon resources in the cloud. As an alternative to, say, using something like CloudFormation, which can get pretty nasty. It's kind of got JSON with shell script commands in it, and it's not very good. So they've been using it for that. However, the reason that I'm giving you this talk as opposed to, or doing this presentation as opposed to one of them, is that they don't actually really care for JavaScript very much, and they pretty much as soon as possible will fork out their configuration processes, configuration tasks to a Python process if they can, or a Ruby process on the Amazon Linux instance that they've got running. So they use Lambda and a small amount of JavaScript to kick off the process, but then as soon as they can, they'll fork out to a separate script. So, and that's a pretty specialized usage of Lambda. So I'm going to kind of focus now on some more general cases, some sort of easier things, just to get you familiar with the basic concepts. I think the example I'm going to go with, we'll do what I call a concatenate function. It's really just a Lambda function that's going to take two inputs, strings, and concatenate them together and return the concatenated string. And on the way through, it'll log them. Now, the Lambda AWS console gives you a really good interface for setting up functions. It's good, really good for playing around with. And all of my examples are going to be using the console. However, it's worth noting that as soon as you wanted to start using this stuff for real on a production project, you really should automate all of the setup of your Lambda functions and wiring them up to events and so on. But we'll use the console for now. And the console is so handy, it even gives you a bunch of blueprints for setting up different types of services. I'm just going to use pretty much the simplest, which is just a little hello world blueprint. We'll call the function concatenate, and we will dictate that it is to use the Node.js runtime as opposed to the Java interpreter. We've got some code here. Now I've kind of edited the default template code that Lambda gives me a little bit. We'll get back into the details of that in a second. You can edit code directly in line, but for more realistically, we tend to upload zip files, and I'll give you an example of that later on. But this sample will be simple enough to edit the code in line. A couple of advanced settings. You can specify the amount of memory that each Lambda instance should have, and this relates a little bit to the billing stuff I told you earlier. And I believe that although you set the memory, in setting the memory also affects the amount of CPU and stuff that's available to your instance. I'm not sure exactly how it affects it. It might be, if you double the memory, you double the CPU. I'm not 100% sure, but I certainly know that it's about more than just memory. It is important to remember, though, that in doing this, you are going to change the amount that you'll build for your function runtimes. Finally, you can specify timeout. That's the maximum amount of time that your function is allowed to run before the Lambda environment will terminate it. You can go anything up to 60 seconds. For the purposes of this demo, 3 seconds will be more than enough. Finally, let's have a little bit of a look at the code for this particular function, just in a bit more detail. Now, because it's Node, this is just a common JS module, so we're going to export an object that has a property called handler. That property is what Lambda expects. The value of that property is a function, and the function takes two arguments. The first is an event, and the second is a context. The event just contains information about the incoming event that's coming into the Lambda function. And really, it's just a JSON object. It's just going to have arbitrary properties in it. We're going to assume, in this case, that the event has two properties called key1 and key2. And the first thing we're going to do is actually log those properties. Second thing we're going to do is concatenate those two values together. And then we're going to use this context object. And the context object is kind of the way in which your Lambda function interacts with its environment. And sends results back, for example. So we're going to just call the succeed method on the context object with the result being our concatenated string. Now how do we test Lambda functions? Another great thing about the console is that you can test them from the console once you've written them. So after it's been created, once you go and look at the functions, we are here, there's a test button that you can use. And you can simulate events being sent to the function, and you can specify what the payload for that event will be. There are even templates for those payloads. The Hello World template just has a couple of keys and values. I'm actually going to tweak that payload just to have two key value pairs in it. One is hello and the other is world. So now when we submit our tested function, and I'll just switch to the real function here. So what we're looking at here is the Lambda function in action, and I am going to click this test button to run the function, and I can see the execution result. In this case it was the string hello world, and also we get some log output. We can see here our two logs where we log the values of value 1 and value 2, or key 1 and key 2, which are hello and world respectively. Some other interesting information that gets written to the logs and just put here on this summary screen is the duration, the amount of time that the function ran for. Lambda rounds up to the nearest 100 milliseconds, so that's what we'll be billed for. It also tells us the maximum amount of memory that we used, which is kind of cool. So that was a really simple example, but it wasn't responding to events. So I'm going to do something a bit more detailed now, and that is image resizing, which is kind of almost the canonical example of what Lambda can be used for. It's so common, in fact, that, or the first thing that springs to mind, and frankly, a lot of this, what I'm about to show you, has just been ripped directly from the Amazon website. But I couldn't think of a better example, to be honest, for background processing and using Lambda. So what we're going to do is write a Lambda function that gets an image, or detects when an image has been added to one S3 bucket, and then creates a thumbnail of that image and puts it in a second S3 bucket. So our incoming bucket will be shine Lambda example, and our outgoing bucket will be shine Lambda example resized. We're going to create another Lambda function here. We'll just call it create thumbnail. And what we're going to do in this case is we're actually going to upload our source code in a zip file rather than putting it in place, and that's because there's going to be more than just one file. We're going to use some node modules to actually do our thumbnailing. So what does the zip file look like? How do we go about this process of zipping things up? Well, firstly, we just on our own machines, we install a couple of node modules. I'm going to install the async module and the graphics magic module. Then we create our little JS file that is our Lambda function. And we'll do this all locally. Then what we do is we zip them up into one zip file, and that contains our JS file and all of our node modules tree, and that's the thing that we upload to AWS Lambda. The contents of our JS file, it's probably worth stepping through. Firstly, we require the AWS SDK. Now, this isn't actually something that we need to install ourselves using npm install. We don't need to bundle it in our node modules. It's something that automatically is available on the Amazon Linux instance that we have. Second thing that we do is bring in our modules that are in our node modules directory. That's async and graphics magic, and I'm just in this case going to specify that I'm going to use image magic. The next thing that we do is take a look at our incoming event, or our function will take a look at an incoming event. Because we're expecting it to come from an S3 bucket, we get information about the bucket name and the key in the event. We then, using that information, assemble or calculate what our outgoing bucket name and destination file are going to be called. Then we sort of commence this series of operations. The first thing we do is download the file, which essentially means that we use the AWS SDK to get the object from S3. Once we've got it, we transform it. I haven't put all the code in here for doing that. It's a little too big to fit on a screen, but needless to say, we put code in here that creates a thumbnail of the contents of the S3 bucket. That then produces a stream of data that we then upload back to the destination S3 bucket. Finally, when that's all done, we call context.done, and that signals to Lambda that our function has finished executing. One final thing that we have to do before we take this for a spin is we have to configure the S3 bucket so that it can notify our Lambda function whenever anything drops into it. So here's our S3 bucket config screen. There's an events section there. If I expand it out, what I can do is say that whenever an object is created inside this bucket, then I want a Lambda function to be called, and the Lambda function is called create thumbnail. And that's pretty much it for that. So let's take it for a spin. Here are my two S3 buckets. Both of them are empty at the moment. What I'm going to do is upload a new file to one of them. So I'm expecting that once this file is uploaded, within a pretty short period of time, a message will be sent to my Lambda function, and it will be invoked. It will create a thumbnail of the image, and then it will dump it back into the resize directory. So the image is going up now. Just in case you're wondering, this is what the image looks like. So now we'll go back to our resize bucket, and hopefully well, there it is, there's our resized image, and we can download it and take a little look at it. And sure enough, it is a thumbnail. So that's fantastic. We have a background task that's executing completely in the cloud. We didn't have to set up any job infrastructure ourselves, and that's one of the great things about AWS Lambda. So there's one last thing I want to talk about, and that's about how you wire up Lambda functions with the API gateway. So as well as events, you can trigger functions via HTTP calls. In order to do that, you use Amazon's API gateway feature, and this is a use case that is quite common, so they've made it so you can actually configure or set up endpoints straight from the Lambda console. You don't even have to crank up the API gateway console yourself. So on the Lambda function console for our Concatenate function, there's a tab called API endpoints, and we can use it to add a new API endpoint ourselves to that function. Adding an endpoint is really as simple as defining a name, saying what function you want it to link up to, and we're going to say that it's going to use an HTTP post to get to it. I'm going to, in this case, make it that it's accessible with an access key rather than just to the general public, because that's probably a more common use case. Having done that, we now have a function listed at a URL that's been generated for us by AWS. So let's bust out Postman and take it for a spin and yeah, see this function in action. So here's Postman here. I've already put in the URL of this function. I'm going to just post some JSON to it, and really this JSON will map directly to the event that's picked up by the function. So this is the concatenate function that we did originally. I'm going to give it key 1 hello, key 2 world. I'll send that call to it. It's loading the data, and I'll just reduce the font size a little bit, and there's our response, hello world. It's fantastic. So we've been able to invoke our Lambda function from a web endpoint. So this kind of is a bit of an eye-opening moment, because what we're seeing here, or what I've demonstrated here, is two tasks that traditionally would have been run on a standalone server. The first, image thumbnailing, would have been done by some sort of background task running on a server we'd set up. The second, accessing an endpoint, gosh, we would have had to run a little HTTP server ourselves, like Express with Node or something like that, or Restify, to expose that endpoint. But now we don't really have to do that. We're just dropping the code into Lambda, wiring it up to API endpoints and S3 bucket events, and it just kind of executes itself. And potentially this is going to be a bit of a game changer for the way that we think about assembling apps. And some people have kind of referred to it as the serverless future. it's in fact such a sort of compelling use case that there's actually a stack out there now called JAWS, which basically just stands for JavaScript and AWS, that is aiming to simplify the process of building a web application using Lambda with JavaScript. And it sort of gives you a whole bunch of boilerplate and infrastructure for uploading your functions automatically from your own machine, testing your functions on your own machine, loading up, displaying static resources, declaring APIs and so on. It's a really interesting piece of tech. It's only about 6 weeks old though, so it's pretty raw at this stage. But yeah, a really interesting piece of technology that's probably worth a presentation in itself. So wrapping up this talk, we've seen that Lambda can be used for a couple of different things. The most obvious immediate use case is background processing, things like image transformations. But another really interesting use case is writing web endpoints with it. And under the hood, they might be using a Dynamo database or something like that. Or frankly, they could use any other database that you wanted. And all of this points to a future that is quite probably serverless, at least serverless in the sense that we think of a server, a monolithic piece of software that handles a bunch of incoming requests. With things like AWS Lambda, I would say that that sort of stuff is going to go away. That said, it's a different set of skills that we're going to have to learn, because writing Lambda functions and wiring them up to, for example, S3 buckets or API endpoints is a skill in itself, and it's something that you want to automate as soon as you can using Amazon's APIs. So the work hasn't completely gone away, it's just the way in which we assemble apps is probably going to change a lot. And in doing all of that work, what we will get is scaling for free and a pretty cheap model for running our apps, because we're only charged for when they actually get used. Thank you very much, and I hope you enjoyed this presentation.